Hello everyone, I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this lecture series, we are going to discuss about circuit breakers, MCB, ELCB, electronic fuses. First of all, what do you mean by a circuit breaker? We know that circuit breaker either make or break a circuit, either manually or automatically under normal and fault conditions. Here, circuit breaker is mainly used to break a circuit automatically under fault conditions like overcurrent, short circuit, etc. See, here we have circuit breaker symbols A, B, C and D. In circuit breaker, we have types. The first one is miniature circuit breaker, MCB. Specially a test designed for to turn off electrical circuits automatically. MCB is mainly used under faulty conditions. Here, MCB is more sensitive to overcurrent than a fuse. Generally, MCB is preferred for less than 100 amps. It is best suits for low current circuits, and MCB's working principle is based on thermal or thermal magnetic operation. Here, one more thing, trip characteristics may not be adjusted in MCB because MCB is more sensitive than fuse. See the diagram of MCB, miniature circuit breaker. Here we have components of MCB like latch, solenoid, switch, plunger, incoming terminal, arc shuts holder, arc shuts, dynamic contacts, fixed contact, DIN rail holder, outgoing terminal, bimetallic strip carrier, bimetallic strip. By using these electrical components, the miniature circuit breaker can automatically break a circuit when a faulty condition. See, the construction of MCB, we have main contacts, trip unit, terminal, housing, trip indicator, auxiliary contacts and trip spring. See here, main contacts which carries the load current and which are connected to the incoming and outgoing wires of the circuit. Trip unit, this trip unit consists of a bimetallic strip, a magnetic actuator and operating mechanism. The terminal, here the connections for incoming and outgoing wires are there. Housing is a protective casing that houses the MCB components and provides insulation. Trip indicator, mainly MCB uses visual indicator. It shows whether the brake is in the on or off position. Auxiliary contacts, some MCBs have additional contacts which is used to switch auxiliary loads or provide signaling functions. And trip spring, this is a spring mechanism that holds the MCB contacts in the on position. When the trip unit operates, the trip spring release and it allowing the contacts to separate and break the circuit. See, MCB working. See the diagram. See, in this diagram we have load, bimetallic element, trip bar, latch, magnetic element, contacts closed here. Contacts are closed with line. See the second one, here the contacts are open. Same load, bimetallic element, trip bar, latch, contacts open, magnetic element and line. Here, when the current overflow occurs through MCB, the bimetallic strip gets heated and it deflects by bending. The deflection of the bimetallic strip, it releases a latch. This latch causes the MCB to turn off by stopping the current flow in the circuit. This process helps safeguard the appliances or devices from the hazards of overload or overcurrent. See the working of MCB. To restart the current flow, MCB must be turned on manually first thing. In case of short circuit conditions, if the current rises suddenly, the electromechanical displacement of a plunger associated with the solenoid happens. The plunger hits the trip lever, which causes automatic release of a latch mechanism. An MCB is simple, easily operable device and it has free maintenance. It can be easily replaced, and here it has a key part trip unit. Here the bimetallic present in the MCB circuit, it protects against overload current, and the electromagnet in the circuit protects the short circuit current. See here. Next one is our earth leakage circuit breaker. Actually, it is used for protecting a person from electric shock and injury. see the diagram. The name suggests it is operated on earth leakage current. It has phase are live, neutral and earth wire connected to the load points through ELCB. ELCB is also known as RCD, residual current device. Actually, this is very important in wiring because the needs of these devices arise because of the number of increasing in injuries as well as deaths because of electric shock. By using ELCB, we can easily prevent electrical injuries as well as deaths due to electric shock. Yeah, next one, ELCB construction and operation. We will see ELCB's construction and operation in our next class. Thank you.